Welcome back to the Foundation in C# course. We are currently in Module 5, and this lesson, we are going to be covering the console app creation. We're going to go ahead and create that front-end console, but not really wire it up necessarily yet. We're just going to get it scaffolded out and get prepared to then put our logic in with our next lesson. So let's go over to Visual Studio. And here's where we left off in the last lesson. And now I'll pick up from here. So the first thing we need to do is add a console application. So right click on the solution and add a new project. We're going to select a console application. So console in the C# language. We have two options. We want the .NET Framework version, not .NET Core, not yet. And hit next. Now I don't get to name the solution here because we already have a solution name. Let's call this Battleship Lite. Now normally I like to have like a console UI in there somewhere, but since this is an actual full application and it's a game, I want the exe that actually runs to say Battleship Lite. Therefore, this is the best way of doing it. Name your project what you want your executable to be named. Now, there is a way of changing your executable name. We can see that, but that does create a little bit of a disconnect then in why is my app called one thing, but my executable called something else. So, but in this case, I think it makes sense. We have Battleship Lite app is the solution name. Battleship is the user interface. And the library is Battleship Lite library. Okay, we hit create. The first thing we do is we add the console.readline at the end. So there we go. Now, if I hit run right now or start, I still get the error that says the project and output type of class library cannot be started directly. Now, one of the things I always encourage you, especially these days, that used to be that error messages were vague and unhelpful. And there still are some out there. But for the most part, when you get an error message, it actually means something. Read it. I don't know how many times I've had people email me and say, I've got this error. What does it mean? And I almost have to say, read it, because that's what this error says is exactly what it means. A project, which solution projects, we have two projects inside the solution. We know what a project is. A project with an output type of class library. Okay. So a class library project cannot be started directly. So what's the problem here? Well, the problem is we're starting the wrong project. We're starting the library. We can't do that. That's what the error message said. How do we start the right one? Well, on our project, we right-click and say Set as Startup Project. Now, it's bold, and if we run this, we're going to get a console which just kind of has nothing in it. It's just kind of sitting there. But it does give me the opportunity to modify my defaults, which you might want to do, might not. It's up to you. I change my defaults to make sure I have the green text, and I change my font size to be something a little bit larger, which is already set to. So now that we have that, we can actually start working on our console application. So where do we go from here? And this may be a point where it's a little intimidating, but don't worry. We already have the roadmap, which you may say, where do we have the roadmap? Well, it's in our user interface design. We walked through this already. So now we know exactly what to do step by step, or at least close enough. And we have the ability then to look at one piece at a time, not the huge picture and get overwhelmed. Okay? Now I'm going to share with you a technique that is well advanced of where you are if you're watching this video probably. It's part of Solid. If you've ever heard of Solid in programming terms, It's an acronym that has, 5 different principles as a part of it. And the first one is the single responsibility principle. That's the S in solid. Now, before you go any further, let me just say solid is not something that you undertake as a rookie. Don't go there. It's too complicated and it makes your code messier until you understand more advanced object-oriented programming and really have a handle on writing good C# code. So don't just try and jump in there. But the single responsibility principle is one of the easier ones to, on the surface at least, understand. And that is that everything should have one responsibility. So every method should have one responsibility, not 3, not 5. Now, how you define that one responsibility is where it gets a bit tricky. So what we're going to do is we're going to create methods that have one responsibility. We're close to it. So instead of main being a whole bunch of code, in fact, all of our application, which you often see in demos, we're going to do this right, and we're going to break it out into methods, because main should have one responsibility. I like to call it the quarterback responsibility. Now, if you're familiar with American football, which that's not soccer or football in the rest of the world, it's football. It's got a quarterback. So the quarterback's job is to control the offense and run the plays. Well, that's what main is doing here, is it's controlling the application and calling the plays. So that's what it'll do. It will just call out the different methods to do different things. It's not going to do much, if any, logic of its own. So let's start by reading through our list from our design. Now, if you don't remember that, I can bring it over here real quick. This is our list I'm going to go through. Right here, we've already done over here on the right, we have the data design. We've already done that. But here is our user interface design. So if you don't already have this written down somewhere in a notebook, maybe take a screen capture or something like that. But this is what we're working from. Okay. So the first thing is the welcome message. Now, welcome message can be 1 line. It can be 3 lines. It can be multiple, different ways of doing it. So instead of putting that right in main, we're going to say private static void welcome message. And that may seem silly, but at the same time, now we know exactly where the welcome message is and how to change it. In this case, we can actually put code in here because it's just a welcome message. It's not actually calling out to anywhere else, and it's only user interface code. So we can do a console write line, CW tab, and say, welcome to Battleship Light. And we can do another console write line, created by Tim Corey. And I'll do a blank one, which is just console write line with nothing in it. So now we have 3 lines here that make up our welcome message. Now we can call this right up here, welcome message. And now we actually print out that message. In fact, if we run this, we'll see that those 3 lines print out to the screen. Welcome to Battleship Light, created by Tim Corey, blank line, and now we're ready to the next line. Now we create user 1 or create the user by asking for information. So I'm going to say that we're going to have a method down here. Let's call it private static, not void though. Let's have it return player info model. Now note that it does not find that. We'll come back to that in just a minute. Then I'm going to give it a name that says create player. So why doesn't it find player info model? Well, because that's actually in a different project, the Battleship Light library. And in fact, it's in a different project in a different namespace. So how do we connect the two? I'm going to show you the easy way and the hard way. Let's start the hard way first. And it's not hard, it's just a little more complex. If you right-click on references in your user interface project, not in your library, in your user interface project, right-click on references, add reference. Under projects, check the box next to Battleship Light library. Hit OK. That adds it as a dependency that the user interface has. So it now depends on the DLL created by the Battleship Light library. Now it's still yelling at us, but we can add a using statement at the top using Battleship Light library dot models. And now it knows, okay, that's where that comes from. That's the hard way. But notice how it's set up. Okay, so the user interface references the class library. You cannot go both directions. The class library does not and should not know about the user interface. So if you right-click on references in the class library, add a reference, and try and check this box here for Battleship Light and OK, you're going to get this error message right here. A reference to Battleship Light could not be added. Adding this project as a reference would cause a circular dependency. Again, these messages actually mean something. So what is a circular dependency? Well, let's think it through. If Battleship Light depends on the DLL from Battleship Light library, let's just call it UI and library, make it simpler. So if the UI depends on the library's DLL, and the library's DLL depends on the UI, how do you build that project? Which one do you build first? Because in order to build one, you have to have the other. But in order to have that other, you have to build the first one. And so it's a circular dependency, meaning there is no starting point where you can build something and then build the next thing and the next thing. As it is right now, we can build the library, get that DLL, the completed build, use that as a dependency in the UI, and then build the UI based upon that dependency. No circular dependencies there. Okay? And that's what we're doing. Now you may wonder, well, how does a library function if it can never talk to the user interface? And the reality is it never should, because then you're depending on the console. What if you want to change it out for a WinForm app or an ASP.NET MVC app? Well, then you still have the console somewhere. That doesn't make sense. So the front end, the user interface, is the one that initiates conversations with the library. Okay, not the other way around. Just want to stress that. Now, just so you know, a library can depend on another library. That's perfectly okay. And in fact, technically, a library could depend on your user interface. It's just almost always wrong to do that way. Okay, so you can go the opposite direction, but it's, again, almost always wrong. I would say 99.999% of the time, it'd be the wrong way of doing it. You've got an architecture issue there. Okay, so back on track. That's the hard way of doing it. Let's undo all of this and show you the easy way. Player info model. Notice I hover over it. I've selected it already. I put my cursor on the info of player info model. and I move my cursor around, it gives me this little drop down here, this light bulb. It's kind of small. And if you catch it just right, you can get it and drop it down. Or if your cursor is on this word that's in red, hit Control Dot. And it brings up this menu. And it gives you a bunch of different options. Now, you do not want to generate a new type. That's only if there isn't already one there. This is for if you create something. We'll do this in a little bit. If you create something that you know is not there, that you then want to create the actual type for. So for example, if I had typed out welcome message before I had this, I could have created then the scaffold for this and then just filled in the blanks essentially. That's what this generate is going to do. Generate a class, generate a class, a new file, a class, generate a nested class, generate a new type. No, we don't want to do any of those because we already have an existing class. But the bottom one is add reference to Battleship Light Library, which is a little misleading because it not only adds a reference, which was how we right-clicked on references up here and add a reference, but it also adds the using statement at the top of our program.cs. So if we click on this, it turns that green blue and we're all good. Notice at the very top we have using Battleship Light Library.models. And in our references expanded for us, we have Battleship Light Library as a dependency. So it did all that work for us with just a Control Dot. Now, if the Control Dot does not work, it does not show you the add using statement or add reference, then probably you have a casing issue. Meaning you type something wrong, you have a flipped character, or you have a lowercase instead of uppercase, or something like that, something small. It has to be exact in order to find it. Okay, so we got this create player method. But what does it do? I think this should do everything that is in that grouping to start off player. So first of all, we're going to create an output for this. So player info model, I'll call it output. That's my preferred way of creating code that identifies what data goes back out of this method if we're returning information. So we're returning a player info model. Therefore, I'll create a player info model. I'll name it output. So I know this is what's going out. That way I don't get confused. Equals new player info model. I instantiate a new version of this class. And eventually I'll return that, but not yet. And that's why it's yelling at me right here with the red squigglies, because I don't have a return statement yet. And that's okay, because we're not done yet. So what steps do I want to do in here? I want to ask the user for their name. I want to, well, first of all, I want to load up the shot grid. Then I want to ask the user for their 5 ship placements. Once I do all of that, then I want to clear the screen and I want to be done. Okay, so those are the steps I want to do in this method. Now this method is going to do a lot of stuff, which again, single responsibility principle would say it should do one thing. Well, it's kind of its own quarterback. Okay, so we got a sub quarterback here. So create player is not actually going to do the real work. It's going to call out the different methods to do the work. So let's start with ask the user for their name. Well, that's very much a user interface interaction. It's not anything we can do in the class library. So private, static. In this case, we want to return a string because it's their name. Ask for user's name. I'm saying users, not user, because username is usually associated with the a login name. And that's not what we're asking for. We're asking for a person's name, but we're calling them user. We could call them player, but we call it user before, so we're going to continue with user. So ask for user's name. So to ask a person for a name, well, first of all, let's create let's do a console write, not write line, console write, and we'll say, what is your name? And then we'll say string output equals console.readLine. What that's doing is it's going to, at the end of this right here, it's going to have a cursor. When they type in their name and hit enter, this console read line is going to capture that and put the string value into output. And then we can return output. So those are our 3 steps in the ask for user's name. Now we can do, up here in our create player, is we can say output, which note we have output here and we have output down here. But they're separate. And that's because remember that everything lives inside curly braces. So this output here gets destroyed once it hits this curly brace. It doesn't live anymore. Now, the value behind it might live if we pass it back out, which we are, but the actual variable gets destroyed. And this is its own scope as well. It's called scope. So these curly braces, this is the start, this is the end. Everything inside here is inside of placements that could be. So how do we do that? Well, that seems like another method. But it seems like that method would be in the Battleship Lite library, not here, because it has nothing to do with user interface. So what I'm going to do is I'm going to create code in the Battleship Lite library. In fact, I'll create a class. So add a class. And let's call this class Game Logic. Keeping it really simple here. I'm going to get public static. And the reason I make it static is because it has no need to store data. This is just methods that I'll use, logic methods that can be reused in other places. Now, since it's in a different spot, sometimes it's confusing to look at what you're doing here and go back over here. But we have options in Visual Studio. If you right-click on the tab, you have the options at the bottom to create a new horizontal tab group or a new vertical tab group. Let's create a new vertical tab group. Now you can see my code side by side, and I can move tabs between different groupings. So I can also change one side or the other to be larger. So it's really convenient. You can actually even segment even more. For example, I can create a new vertical tab group out of this. And now I have 3. That gets confusing. But I think 2 is good for what we're going to do. The other thing you can do is unpin your Solution Explorer. And now you have more real estate to work with. Okay, so you have this shot grid. And I want to call some kind of method over here in the game logic that says fill in the grid. So let's create a method, public static void initialize. I spelled that wrong. Initialize grid. And we're going to pass in a player info model. And we'll just say, we'll call it model. Now notice I'm kind of having a scroll problem here. Let's move it over a little bit. There we go. And I have the same red squigglies here because I don't have a using statement for the model's namespace. I'm in Battleship Light Library, not Battleship Light Library.models. That's because I put my class just in the root of Battleship Light Library. And that's intentional. It's not a model. It's game logic. So how I fix this? Well, again, control dot. The top option is using Battleship Light Library models. We have a preview right here on the right, and it shows us what we'll do. And it's just going to add the using statement for us. That's what we want to do. Okay, so now I've got the using statement up there. And now we're passing in the model. But notice I'm not passing it back. And the reason why is because objects, instantiated objects, so class instances, we don't actually pass a copy of them around. We're just passing around the address of it. Remember, we talked about the idea of building a house, and we use the blueprint, which is a class, to build a house that looks like every other house from that blueprint. But the houses are all different. And we store just the address, 123 Mockingbird Lane, to that house. And if you want to store it in a variable, that variable holds a piece of paper that just says 123 Mockingbird Lane. And so when it looks at that piece of paper, they can go to that location and see the house. So when we pass in the model, we're passing in the same address. So we don't need to pass it back because it's the same place. Whatever we do to that model here will be reflected over here. And this is part of object-oriented programming. So in here, what we'll do is letters.add B. And keep going like this. So let's just copy and paste actually. Makes it a little simpler. So this is C, this is D, this is E. Okay? But if I do my control dot here, it says collection initialization can be simplified. If I click that, look what it does. It takes off my open and close parens. It puts a opening curly brace, and then it puts just the 5 things I wanted to add, close curly brace. So what does that do? Well, it initializes the list the exact same way as I was doing before. It creates a new list of string, and then it adds each of these in turn to the list. But it's shorter, more compact, and less typing. So that's what we're going to do. Now, yes, I could have figured out how to convert letters over into, or numbers over into letters and then do a 1 through 5. That's complicated. Okay? Sometimes in programming, yes, you need complexity in order to get a long-term solution that's going to work great. The reality is, at some point in this application, we're going to have to hard code what letters and numbers we're going to allow. As we progress in our knowledge, we will take hard coding out and we'll pull it in from the app config or pull it from a database or something else. But in this case, we're hard coding it anyways. So this is the simplest and easiest solution. So that's what we're going to do. Don't stress over it. It's great. Okay. Now, again, I could do a 1 through 5 or do some kind of for loop, but instead I'm going to do the same thing as with letters, but with numbers. List of int, and we're going to say numbers equals new, if I spell it right, new list of int, open curly brace, 1, 2, 3, 4, if I can do it right, 4, and 5. Semicolon at the end. And now I have my list of letters, my list of numbers. So that starts us off with the data we need. Now we can start adding these grid items. We can say for each, and we'll say for each string letter in letters. Just going to loop through every letter, starting with A and then B, C, D, E. But instead of for each, we're going to do a for each, and we'll say int number in numbers. So inside of each letter, we're going to loop through every number. And now we'll say model dot shot grid, because this initializes the grid, shot grid dot add, and we can add a new grid spot model item. Now, since it's simple, we could do it in one spot, or we could call this another method from this. Because the fact that it's doing a couple different things, I think I want to call a method. It also allows us to show off another piece of how you work with methods inside of Visual Studio. Now notice my dotted lines here, really nice. It tells me, okay, that's where the start of this curly brace is, that's where the end of it is. Also, I put my cursor on the outside of the curly brace. It highlights the closing curly brace as well. Again, really helpful. So outside the curly brace, I'm going to create another method, but this time it's going to be private static void. And we're going to call this add grid spot. And we'll pass in the model, which is the player info model. We'll add in the letter, string letter, and string number. Okay. Now let's shrink this even further for right now, since we're not using it. So what it's going to do is do one thing. Okay. It's going to take the model and it's going to add a grid spot, so let's create a grid spot first. Grid spot model. Let's call it spot equals new grid spot model. Spot dot letter, spot letter equals letter. Spot dot number equals number. And let's make sure that spot dot status equals grid spot status dot empty. Okay. Oops, I said string, it's an int. Always read why your squigglies are yelling at you. Now notice my IntelliSense here, my little light bulb over here, or again, control dot. object initialization can be simplified. Just like with our lists, we can initialize this and put the curly braces and then put those 3 values inside. So makes it a little simpler. If you don't want to do it that way, that's fine, but that is another option, and it does mean less typing. So now that I have this spot initialized, all I need to do is say model.shotgrid.add spot. All right, that's all it is. So now I can call this right here. Pass in our model, our letter, and our number. And it handles these lines of code. Now note that this right here is public, where this down here is private. What's the difference? Why am I doing it that way? Well, I don't want people calling this directly. That's not for external people to use. That's just for me internally to use as a helper for this quarterback method. Pretty much you're passing back methods that you want people to use and no other ones. No partial methods, no things that do just one thing that's just for internal use. Okay, so this public says for external use. Private says for internal use, meaning you don't even see this as an option unless you're in this class. All right, so now we're kind of scrolling off the page here, but notice these little minus signs. They're really small, but if you click on them, we can shrink down the method to just the signature. Okay, and the signature line it tells us what it returns, what it takes in, and what the name is. Okay, those are the important things of the signature line, besides making sure it's accessible. Okay, so now I know I can call the initialized grid to set up my shot grid. So over here, I can say equals game logic, hit control dot to add the using statement, game logic dot initialize grid. Notice there's no add grid spot. And pass in our output model. Okay, now it's yelling at us and it says, hey, I can't convert. I tried to apply it by an equal statement. There we go. Just call it. You don't have to return any value because again, that's already modifying our output value. So there's no need to return it. Okay, so now you've got the initialized grid. What do we do next? Now, before we go on, I got a little enthusiastic here, and I often do this, but I wrote some logic, which is part of the logic step of this course, not the user interface step. It happens. So in the future, what I'd do is I would just create this initialized grid and then not actually do anything inside here and then implement it in the next step. So we'll probably get to that in a minute, but I just want to point out that I kind of did the next video's work in this video. So it happens. All right. So let's go to the next step, which is to ask the user for their 5 ship placements. Again, this is not going to be work that we're going to do in this method. This is create player, not create player and ask where their ships go. So we'll probably do that down here. And the reason why I'm bouncing back and forth between my game logic and my program.cs is because it depends on if it needs user interface. If we have to have console read line, console write line, console.clear, any of those things, those are all user interface specific. Therefore, they go in the UI project, not in the class library. So ask the user for their 5 ship placements. So let's create a method. make it private static void. If you don't know you're going to return yet, just call it void for now. And then come back and change it later if you want to return something later that you figure out. Okay? So private static void. And let's call this place ships. And we need to pass in that model. I need to know for who do I place the ships. Okay? So we need to place 5 ships. Now, that number 5 is something we'll hard code for now. Because again, we don't have a place to put it. But just know that this is a hard coded thing. So for now, what we'll do is create a do loop. We want to do something 5 times at least. So we know we need to have it do at least 1 time and then continue on if this criteria is true. In this case, the criteria is while model dot ship locations dot count is less than 5. Okay, so if you have less than 5 ships, keep going around. All right, so let's start with the question. Let's do console write and say, where do you want to place your ship? Let's say your next ship. Okay. And we can get rid of, we can move this over for now to have more real estate. So we want to place your next ship, which we can work on the wording of that because the first time you place it, it's like, what, really? But that's what I would do probably is do a check on the count. Maybe grab that count and put it in a variable and say if it's 0, then where do you want to place your first ship? And otherwise, where do you want to place ship number and then the that'll work. Where do you want to place ship number blank? And that way the user isn't confused saying, I already did this. How many more times do I need to do it? Okay. So we're going to place ships. We're going to ask them, where do you want to place a ship? And then we're going to capture the response. So string location equals console.read line. Now, the question here is, do we want to worry about asking them for a letter and then a number, or just have them give us A1 or D4? And I think the answer is just have them give us the actual spot, because that's what they're used to. It's kind of confusing to say D and then 4. Just D4 makes a little more sense, which means we'll have to do a little more work on our end to split that apart. But that's okay. We can do that. So now we have the location, we need to call a method to make sure that's a valid location. So I'm going to invent a place. And notice I'm going to put it in the game logic section, but I don't have it there yet. So what we're going to do is I'm going to kind of show you how you can go the other direction here. I'm going to say bool is valid location equals game logic dot, but I don't have a method for it yet, but I'm going to name one anyways. And let's call this store shot. And we'll pass in our model and the location of our shot. Now it's yelling at me saying, you can't do that. But if I control dot or drop this menu down here, let's generate that method. Notice over here on the right, I now have a public static bool store shot that takes in a player info model. Let's give it some more room here. A player info model and a string called location. That's exactly what I would have created if I typed it over here. Since I called it game logic, it knew to put it over here. Now, it adds this code here that may be a little confusing. It says throw new not implemented exception. Now, we haven't really covered exceptions in detail, but we have covered them a little bit. Actually, I believe we covered this already, but let's just make sure we cover it for sure. So the throw new not implemented exception means that it's going to throw an So we're renaming it over here as well. So place ship. So we pass in our model and our location. And it's going to check to make sure, first of all, that's a valid location. Meaning, if you say Z23, that's not a valid location. Therefore, no, not going to do it. But if you say B4, that's a valid location. But then it's going to check to make sure that you don't already have a ship there. If you do, you can't put a second one there. So it's not a valid location after all. But if you don't have a ship there and it is a valid location, then it's going to return true. If anything fails, it's going to return false. Now, part of that also is it will store the ship if it's a valid location. It's going to put that ship in the model. Again, we don't have to return that. So therefore, if it's true, the ship is placed. If it's false, then we have a problem. So all we need to do now is say if is valid location equals false. Then say That was not a valid location. Please try again. Now, if we wanted to get a little more complex in our return here, and instead of just returning a Boolean, we can return a string that tells us why it failed. Is it invalid grid location, or is it we already have a ship there? But I think this is fine for what we're doing. So that's what I'm doing, is saying if it's false, print the message out. Because it's going to loop through again. We haven't added the ship if it's false. Therefore, it's still ship number 1 or whatever ship we were on again. Now, at the very end, I think what we should probably do is maybe, nope, let's leave it alone. I was thinking of clearing it out, but I don't think that's a good idea. I think we just need to leave it alone and allow them to place the next ship. Now, I could tell them, hey, that was successful, but I think it's a little more compact to just ask them for the next ship location. So it's going to do 5 ships. Once it's done, we'll have 5 ships in the ship's location of our model. Therefore, we're done. So now, place ships comes up here. And pass in our output model. Okay. Now, the last step is to clear the screen, which we can just say console.clear, which you could say, well, let's put it in a method. Well, it already is. This itself is a method called clear. And then finally, we return output. So we've asked for a name, we've initialized a grid, we've placed the ships, we've cleared the screen, we've now returned the created player. So now you can way back up to main, which seems like it's forever ago we started this. But we can say player info model, player 1 equals create player. Player info model, player 2 equals create player. Okay. So that's really all there is to starting off this. Now, the one thing I'm thinking through is maybe we should have which player it is that we're asking for. We just say, what's your name? And how do you know after the first player that it really is the second player? So let's do this. Let's give a name for the player. Player 1, like so, and player 2. And we'll take that in as player title. And so we ask for a name. Before we ask for a name, let's just do this. Let's just do console right line. I should have CW tab. I really should have. CW tab. And let's just say $, or double quotes. Let's say player information for player title. So say player information for player 1, player information for player 2, and then ask their name. So let's just make sure that this works so far. All we're going to do is say the welcome message, gather player 1 information, gather player 2 information, and then be done. Now, it's not going to get very far in player 1 before it throws an exception. But that's okay. So let's start this up. And it says, welcome to Battleship Light, created by Tim Corey. Player information for player 1. What is your name? Tim. And it's going to throw an exception because if you notice over here on the right, we have a object reference not set to an instance of an object. But now we know at least to that spot it works. So if you're reading down through our design, these 3 lines right here encompass the first half of our user interface design, which it seems like nothing of these 3 lines. And it's really easy to actually read, which is another benefit of using methods with single responsibilities, because they're easy to read. Welcome message. What does that do? Well, that's probably the message that welcomes us. Create player. What does that do? Well, it probably creates the player. Create player again. What? Creates the next player. Okay. So, and which player does it create? Player 1, player 2. So it makes it very easy to understand what's going on. And we know that if we look at our design, which let me pull that up real quick. Let's put this right next to this code. Welcome message. There we go. Ask the user 1 for their name and their 5 ship placements. Place the ship, determine its valid spot, store it, clear it. Player 2, all the way through clear. All that is these 3 lines of code. Now, obviously, there's more lines behind that. We've seen that. But that's in the main, it's only 3 lines of code. So we've gone through the first half. I think it's a good breaking point to kind of give you a breather. Now, I'm going to let you just kind of breathe and not worry about doing homework for the next section. We're just going to jump right into part 2. We'll have our tip and our homework from part 2 at the end of part 2 instead of trying to do it now as well. Okay, so we're going to kind of pause right here, take a breath, go walk outside, look over the code, make sure you understand it, make sure you understand what we did, and then come back and pick up in the next lesson when we finish out the second half of our user interface design. Now, don't forget, this is just a UI design, which it's a little more complex with consoles just because the logic also comes into play a little bit. So we've got some logic in here we've already written. But once we've done these 2 pieces, then we'll move on to the actual logic design of making sure these things happen. Okay, which basically comes down to we're going to open up the game logic and make sure that anything that says not implemented gets implemented. And the cool thing is we'll have directions on how to do it. Because we know place ships, it's going to take in the model and location. We have to split that location apart, check it, verify all the rest, and return whether or not we placed it. Okay, so we already have kind of a directions on just this little piece to do. So we're going to get to that in 2 videos. But for now, take a break, like I said, and then come back for the next video.